Although Remington Rand is known for its introduction of the UNIVAC 1 computer, shipped to the U.S. Census Bureau in March 1951, they were also developing, in secret, the Remington Rand 409, an electronic vacuum tube-based calculator for the IRS. The 409 was developed confidentially and remained largely unknown to the public. It was privately demonstrated to invited government and military officials in early 1951, but it was not publicly marketed as a commercial product until a year later, when the technology of the 409 was rebranded as the UNIVAC 60 and UNIVAC 120. The 409 prototype was developed by engineering teams under the direction of General Leslie Groves, former director of the Manhattan Project and designer of the Pentagon. After retiring from the U.S. Army, Groves joined Remington Rand as Vice President of Research and Development, overseeing secretive laboratory facilities in Connecticut, including one known as the Barn in Rowayton, and Remington's engineering facility just 5 miles away in South Norwalk. The 409's groundbreaking modular vacuum tube-based circuitry represented a key evolutionary link, bridging mechanical punched card tabulators and stored program electronic computers. Remington's purchase of the Eckert-Mauchly Computer Company and Engineering Research Associates gave it a major competitive edge in the post-World War II era of computer development. The 409's technology was released after the UNIVAC name gained public recognition, and many 409-type machines were eventually sold. A unique feature of the 409 was a telephone-type dial on the faceplate. The dial was not used to enter ordinary numerical data or as part of a communication line. Instead, the dial was actually a maintenance and program debugging control device. Since the 409 was programmed primarily through a removable wired connection panel or plugboard, during servicing or program debugging, a technician might need to determine precisely what happened at a particular program step. The dial allowed the technician to manually move methodically through the program, step by step, and then use the illuminated panel above it to examine what occurred at each specific step. Each plugboard was wired to cause the computer to perform specific steps. Pre-programmed boards were kept on hand to quickly swap in and out of the machine as it performed its required processing tasks. Wiring of each plugboard was done meticulously by hand, according to written instructions. The tube and cage design. Rather than soldering vacuum tubes directly to fixed chassis frames, the 409 used a modular tube and cage architecture. Individual circuits were housed in removable metal cages or sub-assembly modules. This design made the computer one of the first standalone modular computing systems. If a vacuum tube failed, technicians did not need to perform complex on-site soldering. They could pull the entire tube cage out and swap in a fresh module. Here is a specialized 7-pin miniature dual triode, type 2033, introduced by RCA in about 1958 and supplied primarily to Remington Rand and Minneapolis Honeywell. It was used as a low-power electronic logic and pulse control tube. The date code of 5948 indicates approximately November 1959, making it likely an original tube to our UNIVAC 120 module. 274 is the EIA manufacturer identification code. It identifies who manufactured the tube, in this case, RCA. Our sample module contains 2 of these Remington Rand branded vacuum tubes manufactured by RCA. The date code indicates late May or early June of 1960, suggesting this was possibly a replacement tube. It functioned as a high current pulse driver needed to operate the machine's multiple typed storage tube. Our module also contains 2 of these mercury-wetted armature relays. These are electromechanical power switching components used in the actuator set driver circuitry. The steel case provides mechanical protection and electromagnetic shielding. It was an interface between the computer logic and the card handling machinery. It contains elemental mercury and should remain sealed at all times. This original UNIVAC 120 module, which was nearly identical to 409 design architecture, measures 15.5 inches long by 7 inches wide by 6.5 inches high with tubes and weighs 5 pounds. Each tube cage has 9 pins on one end for the tube's socket compatibility and 10 connector points on the other end, used for testing equipment and heat dissipation. This module is considered a sub-assembly unit and could be removed in its entirety for service or replacement by field engineers. This design greatly facilitated on-site service and reduced system downtime and overall repair costs. With over 1,000 tubes in a full system, tube replacement was an ongoing challenge. The computer used a forced air cooling system for 3 primary reasons. Firstly, vacuum tubes were spread across numerous removable cages rather than packed tightly together. Secondly, most tubes were relatively low-power tubes rather than large transmitting tubes. And thirdly, the modular layout prevented localized hotspots. One of the last remaining UNIVAC 120 machines is on display at the Tokyo University of Science. On the upper right side are several tube and cage panels labeled STL. Just below that are racks of tubes, over 1,000 tubes in the entire system. IBM's Model 604 calculator employed standardized plug-in tube units by 1948. However, the UNIVAC 409 architecture machines applied the principle on a larger, highly visible cage and panel scale for entire sub-assembly replacement if needed. Here are the machine's 2 Plugboard programming panels. Changing a program involved replacing a plugboard with another one, pre-wired. Here is a view of the faceplate with its telephone-style dial. Below it are various voltage indicators and vacuum tube power rectifiers. Although the purchase and lease costs were quite high, UNIVAC models 60, 120, and 40 were very successful up to 1962, selling 1,080 machines. They were replaced by the solid-state UNIVAC 1004, released in 1963, which ultimately sold over 3,000 units.